Hello students, today we discuss about atom. Well, atom means structure of atom. In atom, inside nucleus means in center, we have proton and neutron, and outside the empty space that is known as orbital, in which electron are arranged. So before going to orbital arrangement, that is our topic, we discuss about the who had invented this particular atomic particle. Discovery of proton. Discovery of proton is done by scientist Goldstein. Discovery of electron, that is scientist Thomson. And discovery of neutron, that is done by scientist Chadwick. Again, proton is in the nucleus having positive charge. Electron is in the outermost orbitals, the empty space, that is known as orbitals, that we have to study. Proton having positive charge, electron having negative charge. Because of this, the atom is neutral. Number of proton is equal to number of electron. Another third particle which is present in the nucleus, that is neutron, which having neutral charge. So it is designated by N0. Electron, then it is E-1, and proton, then it is E+1. Now we discuss about the distribution of electron in an orbital. Okay, if atom is there, then in the center it is nucleus. Nucleus containing proton and neutron. Proton positive charge and neutron neutral charge. Outside that, the empty space. In that, electron is revolving. The first area, that is designated by K. K means what? Is equal to 1. Where N is the orbital, then N is equal to 1, then it is K cell. It is known as cell or orbital. If N is equal to 2, means second circle, then K value is equal to 2 or N value is equal to 2. I am designate N is equal to 1, then it is K cell. N is equal to 2, then L cell. Similarly, third. If it is third orbital, then N is equal to 3. K, L, M, N is equal to 4, then N. Similarly, fourth circle. Then N is equal to 4. Then it is, here it is M and this is N series. K, L, M, N series. Another thing, that outermost orbital, the electron which is revolving, is in the outermost orbital, so it revolves fast. Why? Because attraction of proton will be less. Removal of this electron from the outermost orbit, that is also very easy. The energy which is required, that is very less for ionization. Similarly, N is equal to 1. It is very near to the nucleus, so more amount of energy is required to remove electron. Okay. Second rule related with this is N square. Total number of orbital, suborbital. Remember this. Total number of suborbital is designated by N square. Second, total number of electron in an orbital is designated by 2N square. And N designate as type of orbital. Its value is 1, 2, 3, but remember this, N, if it is 1, then only one type of orbital. In higher standard you will study about the types of orbital. Okay, I am giving the name S, P, D, F. So these are the different types of orbitals. Instead of K, L, M, N series, we have to remember the S, P, D, F orbital. So N, if value is 1, then this K, this, but you remember only one type of orbital is. If it is N is equal to 2, then two type of orbital. Similarly, N square will give total number of orbitals. and 2n square, that is total electron in an orbital. The rule which is there for filling of electron, removal of electron, that we will discuss one by one. So rule for adding electron and rule for removal of electron, that we will study. Okay, now we discuss about the rule, how these electrons are filled in these orbitals, that is K, L, M series. First rule, maximum number of electrons present in the cell is given by 2n square. 2n square, already we have discussed. Again I revise. N value designate the type of orbital. Okay, how many types of orbitals are there? N square will give total number of orbital, not electron, orbital. And 2n square, that is equal to total number of electron in a particular orbital or particular cell. First, that is total number of electron is given by 2n. You have multiplied by 2. It means maximum number of electron in particular one orbital is 2. Okay, in one circle 2 electron can be filled. Orbital. Second, if you put n value in different way, n is equal to 1. Then in 2n square formula, n is equal to 1, then answer is coming 1 square, so it is 1, so it is 2. So in first, k is equal to 1, total number of electron field is 2. Similarly, n is equal to 2, if you put the value, then answer is coming 8. So in second circle, maximum electron field, that is 8. Third circle, 18 electron is filled. If it is 4, 4 square means 16. 16 to the 32. So in n is equal to 4, then 16 electron, 32. 16 to the 32. 32 electron can be filled in outermost orbit, that is n. Second rule related with this is maximum number of electron that can be accommodated in the outermost orbit is 8. In outermost orbit, maximum 8 electron can be filled. Third rule, first inner cell is filled, then outer cell will be filled onwards depending upon energy. In short, lower energy, electron first enter into lower energy orbital. If lower energy is completely filled, then second electron goes to higher. So first, if the orbital is empty, then first electron goes inside near n is equal to 1. If this orbital is completely filled, then second electron or new coming electron goes to outermost and onwards. If all the electron in the completely filled, then new electron will goes to outermost orbit. That is rule number 3. Okay, so these are the rule related with filling of electron. Next time we discuss about the valency of electron of all 18 elements. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, 11 number sodium, magnesium, 13 aluminum, silicon 14, 15 phosphorus, 16 sulfur, 17 chlorine and 18 argon. So these all elements we have to write its configuration and what will be its valency. Okay, that we discuss in our next lecture. Okay, thank you.